Hello, am I audible? Can someone please confirm if I'm audible?
Yes, ma'am.
Okay, so let's start today's doubt session. We were earlier we were doing binary card trick and everything. Now we will start with ternary card trick. And first, let me recap what is ternary card trick. And before I start, I will do today's session with iPad. I just want you to join this Menti. So if you have any doubt, you can ask in this. You can just have to scan the QR or join Menti through this code. It will be better if you can unmute yourself and ask directly. But if not, if you hesitate to ask, then you can ask in this comment section or you can ask in the Zoom meeting as well. I think you can scan this QR which is given in the left hand side. I'll wait for like 2-3 minutes so people can join here, and then we will start with ternary card search card trick. So I hope you have studied little lectures for today's like week 3 sessions. So now today we will cover week 3 sessions along with ternary because we have left ternary in the last session. And if you have any doubts in the week 2 or week 1, you can still ask here and I try to clear your doubts. Okay. So let's start with the ternary card trick. Let me first explain what it is and then we can uh, I will ask you some questions, and if you have some doubts, then you can also ask. So let's think like similar to the binary card trick. You will think of a number, and then I will show you the cards. You will tell if it is if it is present or not. But since it is ternary, so each card has three options to you. So in binary, the options were yes or no. In the ternary, it is left, not present, or in the right. So let's think of a number between 1 and 40 and then follow the magic card trick to reveal the number. Okay. Let me ask anyone from the session can give me a number so we can check, or anyone can tell if it is in the left or right. Okay, so someone has said 27. So okay, let's check whether okay we have thought of a number 27. So let's check if this card trick works or not. So let's say in card 1, is 27 present in the left hand side? It is not present in the left hand side, as you can see. But is it present in the right? No. So we will say no, it is not present in this card. Now, card 2. Is 27 present in the left hand side? No, it is not. So in the right, is it present? No. So we will just say not present. In card 3, whether it is present in the left side? No. And in the right? No. So we'll still say not present and continue to the final question. So till now we have asked how many questions? Three, and this is the fourth question we are asking. Is your number bigger than 13? Yes, because 27 is bigger than 13. So yes, it was bigger than 13. So yes. And yeah, it tells you the correct answer is 27. Because since it was not present everywhere, can someone else want to suggest any other number than 27? Okay, someone is saying 1833. Let's go with 18 because it's larger than 13. So let's go with 18. Okay. So is 18 present in the left side? No. But 18 was present in the right side. So we will click on right. Is 18 in the left? No. 18 in the right? No. So we will say not present. And 18 on the left? No. But 18 on the right? No. So we'll say not present. And we will continue to the final question, right? Is it correct? 18 is not here. 18 is not here. 18 is not here. And 18 is not here. But 18 is in the right. So yes, our number was bigger than 18. Yeah. So it is 18. Now, my question to you is, see, how is this actually going, how it is actually working? So let me share you my screen and I hope you can see. So these are the cards, these are your options, and these are the set of questions you are asking. So why is it working? Anybody wants to guess? You can unmute yourself and also express, or you can just type. Um, I guess there are no answers in the Menti as well. And let me check in the Zoom if there are any answers. So one is in the chat. It's 30. Okay, the number they are suggesting is 30. Okay, we tried with, I guess there are no answers. Okay. Okay. Let me, so here why it asked. So like in binary, you put your card numbers like 1, 2, 4, 8, and 16 and present your bits like this. You can do the same thing here as well. You can put in the left hand side the card bit of 1, right hand side card bit of 2, and not present is 0. So in binary, so in binary the numbers are just 0 and 1. But in ternary it is 0, 1 and 2, right? So you can put in the left hand side all the bits which are in 0, like card 1 say represents the number of 3. Sorry, let's say the card bit position of that is 1. Card 2 may the bit position is second, so like it will be 3. And card 3, the bit position is in the second position, so it will be 9. So now it can say on the left hand side all the bits which are saying 0 as an answer, 1 if it is not present, and 2 if it is right, or you can alternate. And just for your sake, the answer you should know, you can arrange cards in any way you like. Now in this card trick, it was of for it was not 0, 1, and 2. They have taken 1, 0, and minus 1. This is as per your understanding how. So if your value is on plus, if your card 1, if the value is on the front side, you will say plus 9. If the value is not present, you will say 0. If your value is on the right side, you will say minus 9. Similarly to card 2, if your value is on left hand side, it will be plus 3, right hand side minus 3, and value not present, then 0. And the card 3 will be plus 1, minus 1, and 0. Similar. And the number 0 and yes answer. If you remember, when you said the number 27, and we said tick on not present everywhere, and we say yes, the number is starting from greater than 13, and then the number present, your magic card number automatically starts and present your 27. That's it. That's the fourth question is where helping you. So if the card was not present, then you are starting with say 27 number. If your card is less than equals to 13, then you will start your number with 0. Let's try with an example. And since a person is suggesting 30, so let's say your number is 30. So is the number present in card 1? Card 1 in the left hand side, you can see that it is not present. In the right hand side, it is not present. So it will be not present. So the value it will put you is 0. In card 2, is the number 30? 30 is present in the left hand side. So you can say left, and it will give you the points plus 3. In card 3, is the number 30 present? No, not present. So you'll say not present, and it will give you 0. And since your number is greater than 13, so you'll start with 27, and that's why the number will become 27 plus 3, which is 30. So that's how this card trick is working. I want you to guess how these numbers are arranged in a way that will be your exercise, that how are these numbers. So now you know how what's the card trick is like. Your number is starting with 0, start with 27. Here is your writing plus 9. Here is your minus 9. Here is 0. And if it is not present, can you think of why how these numbers are arranging now in a way? Like similar to the binary card trick you have to do. But I'll say it's an exercise. You have to think how these numbers are arranging in the cards. Or you can arrange in another different way also. That is also fine. I hope this is clear. So if you have any doubts, you can ask in the Menti as well or in the Zoom regarding ternary card trick. Like how is this working? In Zoom, there is no chat. If you have any doubts, you can ask here by scanning this QR. And can you explain how it is picking? Picking in the sense like how the numbers are arranged, like card 1 may how is left hand side is arranged by these numbers are chosen on the left hand side and right hand side and not present. Do you mean by this picking by means this? Okay. So that's what I was giving you as an exercise. But okay, let me give you a hint. Look at card 3. The numbers which are present are 1, 4, 7, 10, 13, 16, 19, 22, 25. Can you look at and observe a pattern there? If you look at it, then it will be that if you divide these numbers by 3, your answer will be 1. So 1 if I divide it by 3, it is 1. 4 if I divided it by 3, it will be 1. 7 if I divide it by 3, it will be 7. 10 if I divided it by 3 is 1. So that's why the left hand side, the numbers are like this. So if you can look at it, all the numbers when divided by 3 will give you 1. And in the right hand side, if you divide all the numbers by 3, it will give you 2. And not present are only the numbers which are properly divisible by 3. I wanted to identify the same pattern like this in card 2 and card 1. Try this at home. If you can't able to do and find the pattern, then I will tell you in the next session that what are the patterns in card 1 and card 2. The card 1 pattern I've told you, and you can design your own cards like this also. So this is 0, 2, and sorry, this was 0, this was 1 and 2. So if then the card trick be 3, 0, if it is 0, then it was divisible by 2. 1 if it is 1, if it is giving you the remainder 1. 2 if it is giving you the remainder 2. Okay. Someone is asking how to write a number in ternary system. It is same as doing it in the binary system as we did. Let me erase this one. So suppose you want to write 30 in the ternary system. Okay, so I think this will give you the hint as well. Let me say this is not present in this. So 30, if you write into the ternary way, similar to the binary, you have to write 30 into the multiples of 3 to the power 0, 3 to the power 1, and 3 to the power 2. So if you look at 3 to the power 0, it is 1. 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3 is 27. And 3 to the power 4 is 81. So 81 is bigger than 27. So we will first write 30 as 3 to the power 3. Now 27 is already done, right? So what will we have? 30 minus 27? It is just 3. So we know it will be written as 3 to the power 1. That's now you can write this as 3 to the power 3, as in like 1 into 3 to the power 3 plus 0 into 3 to the power 2 plus 0 into, sorry, 1 into 3 to the power 1 plus 0 into 3 to the power 0. So the binary number, sorry, the ternary number will be these initials, and it will be 1010. And if you look at the cards, only the card 2 has 30 in it in the left hand side, and so it is representing you somewhere 1. And if it was on the right, it was representing you 2. So if you write the numbers in ternary, you can see that this is the 101 was saying yes if it is number then greater than 27. So if you ignore this 20 thing and look at just these three, 0 was representing not present, 0 is representing not present, and 1 is representing you to the left. I hope now you can, your doubt for picking the number is also clear. Card 1 left hand side when divided by 3 gives the pattern 102, again 102. Yeah, exactly. Uh, 201, I guess, because when you divide it by 5, it is 201, 201, 201. Yes. This is a one pattern you can observe here. Nice. Card 2 give 201, repeat the pattern. Yes, there is a pattern in card 2 as well. Card 1 give right clicks. Yes, ma'am, it's clear. You couldn't understand step 2? Step 2 of the cards, that how are we saying no and yes to 27 in the ternary card trick. So if your number is saying no, you start your number with 0. So in the mind, when you're calculating, you're guessing the number. So yes, you don't know the number. You will just say 0 plus 3, 0. If your number is starting is greater than 27, you will say yes. So you start, sorry, 13. So you'll start your counting with 13 and then add these numbers like this plus 3 and it will be 30. If you say no, then you start your number with 0 and the number will be 3 in that case. In this card trick, we use the balanced ternary. So it should be 0, 1 and minus 1. Right. Yes, it should be 0, 1 and minus 1. That's what I have said. It will be 1 minus 1. However you want to arrange it in a way. I hope this is clear and you can arrange your numbers like this and go home and try this with your friends as well and made up your own cards. So look at the binary system and you can guess how this pattern is. I want to ask you, why is it so special about 13? Like we are asking why only 13 if the number is greater than 13 or less than 13. Let me look at the Zoom chat as well if someone is writing there. So there's two chats. Ma'am, I couldn't understand step 2. I have repeated it. Is it clear now, Hema? If it is not, then I can still repeat again. Sorry, I was not looking at the Zoom chat. Okay, the question was, why is it so, what is so special about 13? Have anybody answered? What is so special about 13? Like, why are we asking 13 as a parameter? Is the number greater than 13 or less than 13? In this particular example. Okay, I guess there is no answer. Okay. So in particular this, if you take all the front answer, it will be plus 9, plus 3 and plus 1, right? And all the back answers will be minus 9, minus 3 and minus 1. So in total, if all the values are present in the front, your answer will be at max, it can be 13. So can't able to reach more than 13. If so, you have to ask them. If the number was greater than 13, then you have to make a range. So that's why the number was 13, because the sum of these numbers is 13. So if it is the value is greater than 13, so we have to look at the other values. Now, why 27? If it is saying no, then why are we going with 27? If you look at it, 27 minus 13 is 14. So it gives you the answer of all from 14, because we are, if it is in the back, we are also subtracting -9, -3, -1. So it is giving me all the answers from 27 minus 13 to plus 27 plus 13 is 40, from where the our numbers are. So it's giving me the values from 14 to 40, and in the front it is giving me the answer from 1 to 13. So that's why we are ranging it till 13. Can you show the cards? Yes, I can. Does it make it easier to calculate? Yeah, in a sense, but in this is a special case because the numbers are between 1 to 40. So we are making it a range and we are using a balanced ternary trick. So we are using 1, 0, and -1. So if your number is not present in the card 1 and 2, so at max it is giving you +9, +3, and +1. So at max it can tell you the number from 1 to 13. But it will not tell you the number if it is not greater than 13. So you have to ask, if the number is greater than 13, so okay. If you say yes, then now what is the special thing about 27? Why are we starting with 27? Because if we subtract 27 with 13, because at max we can subtract all the back values with -3, -1. So it will start with 14, and at max I can plus these 13 with me. So it will give me 40. So all the rest numbers, that is from 14 to 40, this will give me by this 27 number. This is why 27 is special. 13 present in all cards and 27 isn't present in all cards now. Yeah, that is true. 13 is present in all the cards. That's why it will give me +9, +3, and +1. And 27 is not present, so it will be 0 and it will start with 27 if a number is greater than it. That's a nice observation. Okay. I guess, is there any doubts regarding ternary card trick? Otherwise, we will move ahead and start with binary search and number guessing, which is a week 3 sessions. Let me check in the Zoom as well. Okay, there are no chats. We can move now. Okay. Okay, let's go ahead and start with binary search and number guessing. Just give me a second. Okay. 1 second. You can all also go with this and see the interactives.needara.com, and you can also try these games there as well. And okay, this is the number guessing game. It's not working, I guess. Let me refresh. Sorry for this. In the meantime, if you have any doubts, you can. Okay, I guess this is not working. Okay, you also tried the number guessing and it's not working. Okay, maybe it's some glitch. Okay. Anyways, um, let's s- make the game here itself and represent it in a way. Let's add a page. Okay. I want you to just say yes or no to your answers. And I'm sorry, I don't know who is answering, so I will just see if it is a yes and no, and just go ahead with this. Okay, so let's look at the numbers between for the easier sense. Let's say it is some sorted array. It's a sorted array of 7. So I1 is some number which is, let's say, it can be 1, 2, 3, 4, and 5. But it's not necessary to be that I1 is 1. It can be 50 and it can be 60 as well. So I wanted to find the number, let's say 50. Now, is it good? It will not be good if I ask whether I1, I can ask is I1 is 50 or not. Okay. But this will not be good if I ask I1, is it 50 or not? So let's say I1 says, well, let's say it says no. Then we didn't determine anything. If it is, the numbers can be starting from 51, and we don't know if it is good for us to check it through I7 or not. Or maybe it can start from 17, and then you can again ask, is I2 is 50 or not? But then I2 will still say, let's say no. And it can be possible that you till go this to I7 and you don't find your number if it's starting from 51, 52, 53. So you have to check all the number, all the props. And in this say, the worst case will be 7 because there are 7 numbers. And if there are n numbers, then it will be n. So this is not a good strategy to start with. Again, the similar sense you can start it with I7 and you can ask whether I7 is 50 or not. So if you ask that, maybe it is 14, the number is 14 in the I7 position, and it will say no, and it will say no to you till I1. So you again, in the worst case, you are asking 7 answers, or in the case n, if there are n numbers. So this is not a good strategy that we have to probes all the questions in it. So it can try as many things as possible. But what binary card trick will help, because the answer is yes or no. So let's start not with the left or right. Let's start with the middle. So at least you can erase some numbers, whether I1, I2, I3 will not be there, or I5, I6, I7 will not be there. Let's ask, is I4 the number 50? Let's say it says, if it says yes, then we are done. But if it says no, I4 is not 50, then what do we get from this? That the numbers, sorry, it reveals your answer as well. Sorry for that. My bad from the start. It reveals the answer as well. It says, but sorry. I was presenting some different question. Let me just repeat this again. I'm so sorry for this. Let's say you will check the value of I1. You want to guess the number 15 in your mind, and you will ask what is the value of I1. You will say, okay, it is 14. But you, in this case, you didn't get any answer. That it can be possible that I2, I3, I4, I5, I6, I7 will be, will like, what will be the answer of 14? So you will ask, maybe you will ask and whether want to check in I7 whether it will be 50 or not. So if it is less than 50, then you know the 50 is not here. But let's say I'm saying it is 64. Still, you haven't got any way ki whether I2, I3, I4, I7, in which place your number is. Then again, you will ask maybe I2 and then maybe I6 and go on. In the worst case, you will ask all the seven props solution like this. So whether going in this way, we will go and ask in the middle so that we can erase some cards or some numbers in our way. We will ask I4, what is the value of I4? Let's say it says 14. So now we know that the numbers I1, I2, I3, and I4 itself is less than 14. So our 50 number is not in the place of I1, I2, and I3. So in one case, you reduce your numbers to half. So here it was 7, so you reduce your cases to now only 3. It is not ideally half because it's not a power of 2, so it will 3. So now you will in I5, I6, I6, again you go to the middle and you will ask what is the value of I6. You will say it will be maybe 25. So again you know that I5 and I6 is not the number 50. Then again you just will ask I7 whether what is the value of I7. If it is 50, then you are done. If not, then you will say that 50 is not your solution. So again, we'll get the solution. How many questions did you ask here? That is 1, 2, and 3. In the worst case, you can ask 4, let's say, because when I was saying that number of I4 is 14, let me say the value of I4 is 64. Then we know our solution is in I1, I2, I3, I4 and not in the I5, I6, I7 because the number 50 is less than 64. Then in the middle you will ask again. So it can be possible that you are asking I2 or I3. It is your choice because it's both in the middle. Let's say I'm asking I2 and the answer of I2 is, let's say, 60. Then again, you know that your number cannot be I3, your number cannot be I4, and your number cannot be I2. Again, you will ask I1 whether your number is 60 or not, 50 or not. So in this also, in the three guesses, you get your answer. Now, in the class, you have seen that you can guess your numbers in log to n. Can you guess how is this coming to be log to n? If your number is, if your sorted sequences of n, like here it was 7, there it is n. Can you guess why it is log to n? I hope you understood the binary search and number guessing. For more proper understanding, you should look at the lectures. Okay, let's see if it is. Okay, so no chat from here. Let's see if anyone wants to. Can you explain why it is log to n? Anybody wants to guess? The answer in Zoom as well. Okay. I guess no answers yet also. Okay, let me explain why it will be log to n. There's a hint that after every guessing number, when you guess in the middle, if the number is this, when you ask the number, you get the idea of half of the values. So let me explain this. So if you're starting with n, you first guess the number in between in the middle and your instance reduced to n by 2. So now only you care about n by 2. In the same case, when let's say I will write here and start with, let's say n is 8. So 1, 2, 3, 4, 5, 6, 7, 8. When you ask in the middle, let's say you ask at 5, your first guess, whatever the answer will be, it will be the guess, maybe your value is 50 again. So whatever the value at 50 will be, it will reduce to the, say, if it will say yes or no. So either 1, 2, 3, 4 will reduce, will say, okay, these are not my part of my solution, or 6, 7, 8 is not my part of the solution. In any way, your instance is reduced to n by 2. Now, second guess, again from n by 2, you will reducing to n to the power 2. You have to guessing it till you reduce your, let's say, k is the number of guessing you take till it goes to 1. So that is, you want n to the power 2 to the power k equals to 1, and n is 2 to the power k. And it's a simple algebraic formula. When you put log to both sides, so it will be log to n, and your k is equals to log to n. So that's why your maximum number of guesses is log to n. So if you put n equals to 7, log to n is roughly 3 point like something, because 2 to the power 3 is 8, so it will be 3 point something. And you can, so this will be floor of, I don't know if you know floor of, but your k can be at max 3 point something. And you can look at every chances. At 7, you are guessing your number by 3 chances. And with 8, log to n, with 8 you can guess your number with 3 again. Sorry, it will be 2 point something, and it is 3. Seal. I hope this is clear that why it is log to n. Okay, there is an answer here. If there are 2 to the power n such values, then we will be able to guess it in n plus 1 attempts as we remove half the numbers of the valuation. Yeah. So at each value, we are reducing it at half. Nice observation. Okay, if it is clear, can we move ahead with the next problem of 32 bottles of water, 5 people and 1 poison bottle? If you have any doubts, we can ask in the Menti or in the Zoom. There's no. Okay, there's one comment. We can't guess 8 with 3 guesses. It takes 4 at the worst case. I think it is not correct, because if you take 1, 2, 3, 4, 5, 6, 7, 8. So in the worst case, if you will guess at either 4 or 5, let's say you guess at 4, it doesn't matter. Let's say in the worst case, it says no to these values 1, 2, and 3, 4. Right? In any way, there are still 4 numbers left. If you have said yes to 4, then again 1, 2, 3, 4 have left. So let's say it is no to 5, 6, 7, 8, your answer. Now again, you will look at the middle. Anyway, you can take another anything, 5 or 6 or 7. Let's say you go at again 6. And again, your answer is no. So this is your question. This is your question number 1. This was your question number 2. And again, let's say your answer was no in this case. That was the worst case again. So you will go to 8. This will be 7 or 8. Oh, I see what do you mean. You meant you have to ask one time again. Yeah, maybe you are right that it will be uh log to n plus one maybe. Then to finalize your answer, it is yeah. Finalize your answer, it should be log to n plus 1, but you can narrow it down to till 1 because it is till 1 answer you are getting in log to n, but you have to again verify that one number. For that one value you will have to use it is log to n plus 1. Yes, you are right, because again we will ask 7 or 8, so either one of it can say no in this case, and then you have to ask 8 if it is yes or no, and then you will ask it. So yes, I think you are right, it is 4. Is it any clever way? Yeah, I think it is 4. Nice. Okay, any other doubt? But if I tell you your number is in this sequence, then you don't need that plus 1. But here you don't know your number is in the sequence or not, so you need that plus 1. No doubts, man. Okay. So we can move ahead with 32 bottles and 5 people and 1 poison. So in this thing, we are asking that there are 32 bottles in the present there, and you have 5 people, and out of these 32 there is one poison bottle. You want to identify which bottle is poisoned. So you know binary, so you know first you can observe one thing directly. If it's 5 there is 32, so you know that 2 to the power 5 is 32. First thing you should observe this always. Now how we solve this, we will just like binary, we have the card system with us. We will ask whether card 1, like card 1 what are the values which have bit 1 in it, card 2 which have second bit 1 in it, 4 and third bit 1 in it, 8 1 and 16, like the binary card trick we did. So we will give person 1 the card 1 bottles numbers, it is person 2 the 2 bit bottles, person 3 3 bit, person 4 4 bit, and person 5 5 bit. Then again we will check. So the poison, whoever has drunk the poison bottle would have died. So let's say your poison was in the second person, fourth person, and fifth person got died. So you know the poison bottle is 2, 8 plus 16, which is 26. The bottle number 26 was poisoned. I hope you understood this 32 bottles of water. Again, I'm saying because because since it's a doubt session, so I'm just recapping what was happened in the week. But if you want to observe how is this happening deeply, you should go ahead and watch the lecture series. So this is just a recap for me, and I wanted to ask some interesting questions in this, and I want to know whether you have some doubts in it. So I wanted to know if bottle, let's say I'm giving you a bottle, that bottle 13 is poison, then which person will be alive or dead? Like person 1 will be alive, person 2 will be alive, person 3 or person 4 or person 5. This is my question to you. If the bottle is number I'm telling you is 13 is poison. So in the same pattern I'm giving poison 1, poison person 2, person 3, person 4 in this way. So which persons will be dead and which persons will be alive? So this is a reverse question. I'm not asking you what is the poison bottle number is. I'm telling you the poison person. Poison number, bottle number is 13. I wanted to ask which person would have died or lived. Okay. Person 1. Please write whether alive or dead because I'm asking both the questions. Whenever you're writing person. Again, person 3 is random for me. Please, if you can say what are the persons alive. This is person 1, this is person 2, this is person 3, this is person 4, and this is person 5. 1, 3, and 4. Okay, I think you meant by poisoned, which will be dead. Okay. 1, 4, and 8 person. Okay, you meant by person 1, person 3, and person 4 because this is card number and not the person. Person 1, 3 will face effects or die. Okay. 1, 3, and 4. 2 and 5 will live. 1, 3, and 4 will die. 1, 3 will dead. Okay. I guess you understood the pattern here. That you have to rewrite 13 in the binary system, and 13 will be written as sum of 8 plus 4 plus 1. And that's why the person number 4, person number 3, and person 1 number 1 will die because there is a unique representation of every binary number. 2 and 5 live, 3 and 4 will pass away. Yes. Yes. Like, what if there are 64 bottles now? So, how many persons you need to verify the poison bottle? I want to ask now how many persons you need to verify what will be your poisoned bottle will be. If your bottles are now 64, not 32, but 64. Which happens soon. Okay, one person is saying 6. And 6. Okay, and 6. 3 of them are saying 6. I hope these are different people because I can't able to see if they are different or not. Okay, again 6. I should show the be here as well. 6. Okay. I hope you understood why it will be 6 because again 2 to the power 6 is 64. And so to get a unique representation, you need 6 persons. Nice. Here there was 2 to the power 5, so we need 5 persons. Here 2 to the power 6, so 6 persons. Okay. Let's move ahead and start with 9 floors and 2x. And let's recap this one. So here you have 9 floors. Okay. One person is saying 7 persons. No, there will not be 7 persons because 2 to the power 6 is 64, and each person you can similarly give 6 person the set, one for 15, 16, and one you can give it as 32 starting from. So it will cover all the 64 bottles in a unique way. So it will not be 6, 7. So it will be 6. 2 to the power 0 is also a person. That is what representing 1 is. 2 to the power 0 is 1. In the 32 also, 2 to the power 0 was first person, 2 to the power 1 was second person, 2 to the power 3 was, sorry, 2 to the power 1 is second person, 2 to the power 2 is 4 person, 2 to the power 3 is 8%, 2 to the power 4 is 16%, and 2 to the power 5 will be 32%. For instance, if I tell you there is one bottle, how many persons you need to verify? You need 0 people in this case, because you know that will be the poisoned one. If there are 2 bottles, you need 1 person to verify it, because that 1 person will die and the other will be the poison. That's how you can make it, extend it to the 64 one. I hope this is clear. Shall we move ahead with 9 floors and 2x? It's not clear that why 2 to the power 0 is 1 is that is the person 1 which I'm saying. Clear, okay. One is saying clear. Okay, others are also saying clear. So let's go ahead. And 9 floors and 2x. So in this case, you are given 2x and you want to identify at which floor your x break, and to the next floor it will be safe. So break and safe in the sense, this is not a normal egg, this is a tangible egg you have. So if you break it from third floor, let's say, if it doesn't break, so it will not break from 2 and it will not break from 1 as well. So that is the egg is like. And if it is break from 7th floor and it break, then it will break at 8th floor and it will break at 9th floor as well. So let's represent yellow with safe and represent this red as danger, and it breaks it. So now, if in the same sense the number guessing thing, if we start, it's a magic egg, right? Yeah, let's say it's a magic egg. Otherwise, I'll just drop it from my hand, it will break. Okay, let's say if I break, if I drop my egg in the first floor, notice that we only have 2 eggs and we have to tell the answer with just 2 eggs. Let's say we break the I drop my egg from the first floor and it survived. So it will survive in the lower eggs as well. 2 it will again survive, 3 again survive, 4 again survive, 5 again survive, 6 again, 7 again, and 9 also survive. But this is, it takes you like 9 steps to answer that it survived with all the floors. But it's not necessary that it will survive. Maybe you start from 9 and I'll say that it breaked at 9. Then you will ask it, you again break at 9, 7 break, 6 break, 5, 4, 3, 2, 1. So again, this is not a strategy to ask break 8 and 7. And again, by the way, if you breaks at 9 and 8, you lost your 2x and you can't tell anything. So it's not even a question to ask 8 again to x. So let's say if breaks at 9, then you don't know any solution and you will start, because you just have 2x. They will ask first floor whether it's break, you say survive, 2 survive, 3 survive, 4 survive, 5 survive, 6 survive, 7 survive, and let's say 8 also survive. So you know that the floor where it starts breaking is at 9 and survive till 8th floor. But again, you are asking 9 questions. Again, we want to reduce the number of questions we are asking. So let's use the same strategy that we use in the case of binary guessing. Let's start in the middle. Let's ask, let the middle will be here 5. Let's ask 5 whether the egg breaked or saved. Let's say it breaked it, because in the worst case, it will break at 5 and we will be just left with one egg. So let's say it breaked at 5. So now we know that it will break at 6 and it will break at 7 and it will break at 8 and it will break at 9 as well. We only have to check with now these numbers 4, 3, 2, and 1. So let's say then, since because we only have one egg left, so we'll check at 1 and if it is survived or not. We'll check at 2 if it survived or not. Let's say at 3 it breaked. So again we know that at 4 it will break. And in the worst case, we asked this questions. We asked 2 plus 1 plus 1, that is 4. In this case, if at 3 it breaks, but it is not the worst case. The worst case will be if it's again survived at 3 and again survived at 4. So in the worst case, you have asked this question 1 whether it will break at 5 or not. Then you asked question 2 whether it break at first floor. Question 3 is whether it break at second floor. And question 4 is whether it break at fourth floor, third floor. And to confirm, you will ask question number 5 whether it break at fourth floor or not. So in general, you have asked 5 questions. It's again dividing and question answering the question. So it will be just if you say do the same strategy with n floors and 2x, you will check it n by 2th floor, which will be first question, and then you have to check it all the n by 2 floors to whether it is survived or not, like in this first floor, second floor, third floor, fourth floor. So it will be like this is just question number 1, and there here there are question n by 2 questions. So it will be n by 2 plus 1 questions. I hope this is clear. That this will be the worst case in 2x. Since there are 2x, so you will use the binary strategy in this case also. And you can verify that any other strategy you follow will lead you more than n by 2 plus 1 case in the worst case. If you are lucky, you can answer it maybe first also. Rocket breaks at 5. Is this it's clear? By n by 2 plus 1 will be the worst case. Hmm. Now let's do the same thing with 9 floors in 3x. Okay, I think our time is up. So you should try this maybe at home. So what will happen if it was n by 2, it was n by 2 plus 1 if there are 2x. If there are again same 9 floors and you have more eggs, then what will be the strategy you should do? Maybe you should, if you don't get your answer, you should check the week lectures and you will get it. Okay, let's stop here. If you have any doubt, you can still ask in the Menti or in the Zoom. Otherwise, this is the end of today's sessions. In the next session, we will try to do 9 floors and the box and the cat. Mm. If you have any doubt, you can ask here. Otherwise, you can. Okay, no doubts. Or maybe you can ask in the Zoom as well. Mhm. If you have doubts and you are hesitating here as well, you can ask in the Google form, which is maybe provided to you. Mhm. I guess there are no doubts. And maybe we should just end this. Okay, there's one chat. Thank you, ma'am. Thanks for coming. Okay, let's end this presentation. Thanks for you to come and we will meet in the next lecture. Yeah, you're welcome and thanks for coming.